Good afternoon and welcome to Johnson Space Center. And this afternoon we have with us the STS-51 crew to narrate film from their recent mission. And next to me is the commander, Navy Captain Frank Culbertson. I'll turn it over to you, Frank, and let you go ahead and introduce your crew.
Thank you very much, Barbara. And good afternoon to everybody. It's a pleasure to be back here at JSC and have the opportunity to talk to everybody about what we did and show you some nice pictures and we hope an interesting video. I was the commander of the mission, very fortunate to fly with the people to my right here. Immediately to my right is Bill Reedy. Bill was the mission specialist and orbital pilot on STS-42, and for this mission he was certainly our orbital pilot and did a lot of flying on the orbiter. He was also our mainstay in systems management and provided us with a lot of continuity on a day-to-day basis in making sure that the orbiter operated properly and was well cared for. Bill is a graduate of the Naval Academy, a Navy test pilot and attack pilot, and a terrific guy to fly with. To his right is Dr. Jim Newman. Jim is a graduate of Dartmouth and Rice University with advanced degrees in physics. Jim was mission specialist number 1, primarily responsible for the ORFEUS-SPAS payload, as well as being one of the participants in our EVA. Jim was on his first flight and is a member of the 1990 group of astronauts. To his right is Commander Dan Bursch. Dan is a Navy bombardier navigator by background, trained at Naval Test Pilot School also. He's on his first flight as mission specialist number 2 on this particular flight, responsible for acting as a flight engineer during ascent and entry, during rendezvous operations, and also was backup to the AX-TOS payload and was our primary operator for the remote manipulator system, which was, of course, a key ingredient to this flight. And Dan, again, a member of the 90 group and on his first flight. To his right is Lieutenant Colonel Carl Walls. Carl was also a member of the 90 group. Carl is an Air Force engineer with a background in nuclear physics. He's a graduate of Kent State University and John Carroll University, and was primarily responsible for the AX-TOS payload on flight day 1, as well as being a member of our EVA team that went out into the payload bay to evaluate tools and procedures for the Hubble Space Telescope repair.
You could see a little sliver of a moon the morning before we launched, and that all went away. You can see that try number 4, we're pretty well practiced at the suit room routine, and we're anxious and raring to go here.
They make you wave a lot.
We also got in step. You can see the 4th time we managed to get everybody in step, everybody in the proper alignment there for the walk out to the Astrovan. Just after sunrise, we got down to T-3 seconds, and the main engines were still running, and the vehicle was rocking back and forth, and you can see the SRBs lighting up, and that's when I told Frank I was starting to be excited. And it was sure an exciting liftoff. Shake, rattle, and roll, and clearing the tower and everything was just an incredible ride. The roll program and everything, I don't think you've probably heard a more excited roll program call in the history of the shuttle program. Just a spectacular day to go fly, just like the other 3 opportunities had been. You can see we're just going straight on up there. There aren't even any perturbances to the plume there. I mean, it's just a spectacular day. This is what I told everybody was going to be the train wreck, where the solids come off and there's a huge structural ring through the vehicle and everything else, but I guess with all the rocking and rolling Discovery did on the pad, everything came off very smoothly, including the external tank. And this is some great footage that Jim Newman got of the tank. Now we're in the post-insertion, doors are coming open, and we're about ready to get to work.
Well, the first item on our agenda was the AX-TOS. Here is the AX-TOS being tilted up. We had already rotated the ASC open. And this is the aft flight deck here, and AX is all tilted up. Dan was watching the currents while we were tilting up, watching the motors, and he had his fingers crossed that this would be the time to deploy. I hit the fire switch, and away she went. You could see this through a camcorder video. Is just amazing visuals as it came up and over the flight deck and out across the ocean there and the clouds. This spacecraft is on station right now, doing great during its checkout period. You can also see some of the debris that came out too. We had both super zip explosive cords fire, so that followed us around during the mission a little bit. Now, the AXTOS was on a timer, and 45 minutes after the deploy, Dan maneuvered the arm around the space shuttle and around on one of the wings to get this picture of the TOS motor burning and sending it up to Earth orbit.
At the end of the robotic arm are these wire snares, and that's the first half of a good grapple. And what we do is maneuver it using this cross-haired target, and from that target I can tell if I'm off axis, and I just get close enough. There's a pin on the grapple fixture what the wire snares will wrap around. That's the first half. And then they retract inside the end of the end effector and then give us a good grapple. There's Frank wiping a little sweat off my brow. No pressure there. Here's the ORFEUS-SPAS unberth. Again, went very well. Much attribute that much to the great training that we went through here. Flight deck was very crowded there, and that was Carl maneuvering the IMAX camera. We tested the door of SPAS prior to release. It was actually a command sent by the ground, but that's actually in the release position over the payload bay right now. Again, there's Mr. Bill in Frank's seat. Unfortunately, he didn't get to look out the window quite as much as we did, but you'll see later here he gets kind of surprised by one of their surveys. And again, this is prior to release, and at the moment of release, I press a button and or trigger switch. It opens the snares, and I pull away with the robotic arm.
The next thing we're going to do is, if you recall, the IMAX camera and the EMU TV on there, we started receiving that back. So this is the SPAS actually taking a look at the orbiter, and we were able to set up and do all the maneuvers, as you can see here. And then this is us looking back at the SPAS as it takes pictures of us. And so what we're really looking forward to is when the IMAX film comes out, and I believe that there may be a general screening of that sometime in the future for JSC folk. It will be looking like this, except for with IMAX quality. At night, of course, we were shining a flashlight at it in order to try to see if it could see us. One of the things we also did was a maneuver. The Rickel roll, Ted Rickel designed this one. It's sped up a little bit here. It's blooming a little bit because of the EMU TV camera doesn't have the range in order to be able to handle all that. But the IMAX is supposed to have been set right and should handle this, and so you can get a number of different views of the orbiter as it does its rotation before we then ended up doing our final separation away from the SPAS in order to go into our week-long sort of station keeping. So here we are. These are the payload bay lights on the orbiter, and there's that little flashlight that we were shining.
Once the ORFEUS-SPAS was deployed, we had our LDCE experiment that we activated. It's a getaway special gas can. It has material to be tested for future space applications. We called it Oscar and Albert.
On the DSOs, again, we saw this one earlier. There's the goggles going opaque. There's the targets. You can see the little laser.
This is the Advanced Lower Body Restraint Test, affectionately known as Albert, and it really benefited, especially myself, being a little bit shorter on the aft flight deck, and being able to see out the window and reach all the controls of the RMS. It worked beautifully, and Here I am changing contacts. I was the only one who flew with contacts on the flight. It took a while to get used to a technique that would work. And what was kind of interesting is that the solution that I used, I actually preferred a thinner solution in space just because of the surface tension, which it kind of caught me by surprise. Fortunately, I brought both kinds with me. It worked well.
There's the HRSGS, the high-resolution shuttle glow spectrometer, just a demonstration of how easy it is to move large objects around in zero gravity. Here we are with Dan doing his cycle ergometer workout, and Bill decided to take a little jog with him. I think they covered about 12,000 miles during a part of that.
That was the low-impact treadmill.
The opportunity to have a bite to eat after a long day, that squeeze steak I've got there is why I'm smiling. Really quite good to have a chance just to relax a little bit and have a bite to eat down on the mid-deck. These are little Teddy Grahams, and there's a shark sequence with one of these where one of them disappears. I think that got cut out of this. We also, with deference to our many medical experiments, we had a guinea pig on board. That's how we sort of felt. And this is the guinea pig shots, as we fondly called it.
These are some scenes of the EVA preparation. Like everything else we do, we've got checklists and make sure we go in very great detail into the test and checkout, particularly of critical components like the space suits.
This is the power ratchet tool that we're demonstrating. There's the tool itself and the controller, and also the torque limiter, so that we wouldn't over-torque any of the bolts. Here we are in the airlock. We're doing our pre-breathe here. We did 40 minutes prior to depressing the airlock. And there's not much you can do except hang around and smile and wave, and that's what we did. And this is the egress from the airlock. As I was going out, it just really struck me how familiar this was, and it just have to hand it to all the training that we had in the WETF. Really prepared us well for the experience of going out into the payload bay. And we went right to work. I'm out there on the port side getting Jim's tether. He had a new tether that we were checking out.
There we are setting up one of our work sites, and I'm putting a bridge clamp there in order to be able to later on set up the Hubble Space Telescope portable foot restraint. Carl is doing his translation technique there on the left, you can see, as I'm setting up one of the bolt probes there. And this one works a lot better than other methods. Once you're up in space, it's painful in the water tank because your head's down like hanging from a high bar. But we were then able to set up our work site in this area here.
And I'm at my work site forward with the power ratchet tool. And
then we're able to test out. You can see one foot's out, and we're doing is testing the pitch. And with one foot out and the other one firmly in there, we're able to position it and pitch quite easily. It's more interesting in yaw. There's have to be fairly careful in order to avoid having the one remaining foot come out of the PFR. And it also shows, I think, in the next one, we'll show a close-up of how the foot is actually doing the pedal movement. So with this, you don't have to get out of the PFR in order to reorient it, which is much more effective. And there you can see the boot pushing on the pedal, and then the other foot is doing its little torque routine in order to move it around. The PFR two-step, we called it.
And here I am working with the power ratchet tool, and it worked quite well. You had to keep your body rates under control. We didn't have a foot restraint for that task. The Hubble folks will, and I think that will help them a lot. What we found is we could do these torques up to 38 foot-pounds, but it made it easier. It would definitely make it easier to do it with foot restraint to be able to help keep that body under control. And that was the flight deck scene. We had great help from Bill, Dan, and Frank. They're keeping us on the timeline and doing a great job on the photography.
Well, there were some incredible Earth views as the EVA was in progress, and this is the Skeleton Coast, Namibia and Africa. Some of the views almost made it look like the planet Mars underneath. The Earth was so red. The only snag we really had during the EVA was when the PSA door jammed. And you can see here's some footage of after getting some help from the ground here and selecting the proper tools for the job, unjamming it.
And here's our sign.
And the group shot. The guys are in the window. Well, next thing was our next big event was the rendezvous, and here's Bill performing some of the burns in preparation for the final intercept. And Jim set up with all his computers, and in a moment you'll see one of the trajectories that was generated. This was the projected TI burn, the intercept burn. And here's the commander with not much to do while everybody else is doing all that work. The SPAS was visible there probably at about 12 miles. Dan was using the handheld laser, which he was able to use very expertly. He got a mark out to 8,700 feet, which is the best we've ever been able to do with the handheld. There's the SPAS through the COAS at about 400 feet. And Dan was calling marks, feeding them to Bill, who was feeding that and radar data into the PGSC, and giving me good calls on what he thought we needed for braking or corrections. This is the SPAS at about 200 feet, slightly aft, as we were approaching at about 0.1 feet per second, 0.1 foot per second. Dan in the aft window, watching for this to happen. This is the view from the end effector as we brought it down into the payload bay and tried to get the grapple fixture as close to the end effector as I could, so Dan didn't complain too much. But at about this point, Dan was saying, well, I'm getting ready to take the brakes off, and I said, okay, you got it, free drift, it's yours. And he said, wait a minute. But he did a great job and grappled very expeditiously, and you can see how cleanly and on target he came into the grapple fixture. This is sped up just a little bit for the RMS folks that might be getting nervous out there. But the object is to keep that little white dot inside that little white circle, and he did a terrific job. And there's the grapple. And of course, we had a lot of activity to do after that, including getting set up for the RICS camera operation as well as some manual flying on Bill's part. Bill, if you want to explain.
Well, this is, I think, a pretty unique and spectacular view of the forward part of the orbiter. Dan was flying the arm with the Orpheus on it, which had that IMAX camera, as well as the boresight camera, which was giving us these views. You can see the 3 forward-firing jets, the 3 up-firing jets of our reaction control system, and the keyhole there, kind of in front of the windows, is star trackers. Flying the Orpheus around the orbiter, we did a pretty thorough survey, and this is sped up a little bit also. You can see going along the port sill. There are the V-guides where Orpheus is going to go back, and you can see the MPM, which is what supports the robot arm. Over across the bay, if you look very closely, you can see the ERPICL, our extended range payload communication link. There's the other part of the arm, and this is, I guess, probably one of our favorite views here. You can almost count threads there on the tiles and the blankets there for the thermal control system.
Where Bill looked outside, we said, take a look outside, and next words out of his mouth were, holy mackerel, when he saw the payload out there.
You can see the IMAX there in the window. We're trying to get IMAX of them taking IMAX of us. A little bit of cinema verite, I guess. As Dan goes back and bursts the ORFEUS-SPAS back in the payload bay.
That's also sped up.
We did have a chance to look out the window a little bit. This is part of a photo frenzy in progress. We had some spectacular views, and unfortunately the video doesn't quite do justice to some of the views we saw. This is Australia, and the turquoise and blues of the water and the contrast with some of the really intense red of the land was just spectacular. You can see a little bit of sun glint down there in the bottom center portion of the picture. It really does highlight the little streams and tributaries that you wouldn't ordinarily see. This is taken out of window 6 on the pilot side, and we're going to zoom in here, and what you're seeing is the city of Brisbane, Australia. And it just turned out, we wound up with a night landing because with our takeoff time and a 10-day flight, the United States kept on getting darker and darker and darker. And that meant that halfway around the world, of course, Australia, we had some spectacular views that were always sunlit. This is a view of South America, and you can see what almost looks kind of like Edwards, California, and dry lake beds that they call salars up there in the Andes Mountains. Once again, some really incredible contrast between the really blazing white of the dry lakes and some of the reddish dirt that surrounded it. The winds in that area of the world blow at like about 80 miles an hour across those lakes. This is Madagascar. It's been photographed quite a bit, and we do that on just about every shuttle flight to document the erosion that we are seeing and the silting up of the harbor there at Betsaboka. And once again, the sun glint is pretty evident. This is Africa at night, and what you're looking at there are thunderstorms, and I think the size of the frame there is probably about 200 miles on the side, so you can see just how widespread the thunderstorms are and just how incredible the electrical activity is, especially when you view it on a large scale like that.
Well, eventually it was time to start wrapping everything up, and we got ready for the second deorbit day. Got up that morning pretty much ready to come back home. All we had to do was get into our suits and get into our seats and run through the timeline, get everything stowed. Put all the film in a bag to bring it back to Houston, and you can see it's a lot easier to handle in zero-G than that heavy bag was after we landed. But that's a lot of different examples of our film. This was actually the first deorbit day when Jim had not arrived on the Carl's big and small rack in the corner. But here's a shot of the Terminator. You can see that the orbiter is traveling from light to dark. The Earth underneath is dark. The orbiter is still sunlit for quite a while, about 4 or 5 minutes after the Earth experiences sunset below us. The entry itself, of course, requires about 4 hours of work prior to re-entry. There's Jim with his 51 and all his electrodes on. Everybody's suited up at this point, just about ready to do the deorbit burn. About a half an hour after the burn, we begin what we call entry interface, and this is the light show you see outside. I didn't see this on my first flight because we re-entered in daylight, and I'm not sure how I'd have felt if I'd have known what was going on out there, but it was pretty spectacular. This shot was taken with an infrared camera, probably over Orlando or in that vicinity. You can see how hot the leading edge of the wings and the nose cap are. Just prior to us rolling over onto the hack, coming across the coast, the Atlantic coast of Florida. We rolled out on final, followed the guidance, and ended up over the runway, and there's the touchdown just as we come into the view of the xenon lights that illuminate the runway for us, since the orbiter does not have a landing light. Bill deployed the drag chute just prior to derotation, and that worked very well. It's a modified chute that we think is an improvement over the ones we had before. Helps with the deceleration as well as the stability of the orbiter during rollout. You can see the nose wheel touch. We rolled out about a little less than 9,000 feet, and And here's the jettison of the drag chute. This is a view from the nose of the orbiter, looking back down the runway. And there goes the drag chute at about 60 knots. Came to a stop